Hello again. Now, second part. We will solve some problems for conservation of energy. So now we'll solve question number 5. This one from random. Question number 5. So let's read it carefully. A 25 kilogram box sliding to the left across a horizontal surface is brought to a halt in a distance by a horizontal rope pulling to the right with 15 tension. How much work is done by tension and gravity? So question is work. So we know that work equal to force times distance. So here we have two questions: work done by tension and the work done by gravity. It means by weight. So we know that we have a horizontal surface and 25 kilogram mass, and force applied to the left with the force with the tension 15, and it moves in horizontal direction. Yes, for 35 centimeters. Centimeters. So first, let's find work done by tension. So it means work done by tension, in this case, tension times x. So pay attention. Direction of tension is horizontal, and it moves in horizontal direction. So this is what we need. So work done by tension equal to 15 times 0.35 meters. So we need to use distance in meters. So answer will be, let's use our calculator. Answer will be 5.25. Work done by tension 5.25 joules. Now let's come to the work. Work done by weight, gravity. Yes. So let's draw the gravity. So this is the weight, mass times gravity, which is equal to 25 times 10. Weight equal to 250 newtons. Be careful. Work done by gravity equal to 0. Why 0? Because this object, this box, is not moving in the direction of the weight. It's moving in horizontal direction. Weight is a vertical, so angle between this distance and the weight is 90 degrees. So that's why work, basically, box is not moving in the direction of the weight. That's why work done by weight equal to 0. Next question, question number 10. The cable of a crane is lifting a 750 kilogram girder. The girder increases its speed from 0.25 to 0.75 meters per second in a distance of 3.5 meters. How much work is done by gravity? How much work is done by tension? So first, let's draw. This is the question number 10. Let's draw a figure so we could imagine, yes, what is happening. So here we have a tension. Here we have a weight, and it moves from this level to this level, and the distance between these two levels is 3.5 meters. 3.5 meters. So initial velocity basically at this point is given, and the final velocity at this level, at this point, is also given. Yes, 0.25 and 0.75. Now we should find work done by gravity, by weight. Yes. So we know that work is equal to force times distance. In this case, force is equal to weight, and we should find. First, we should ask this question: is it moving in the same direction as the weight? So weight is vertical downward, and it's moving in vertical direction. So it means weight is doing some work. because it's moving in the same direction. It's not the same direction at the same dimension. So but be careful, weight is downward, it's moving upward, so it's moving in opposite direction. So work is negative. Work should be negative because it's moving in opposite direction. Weight is 750 times gravity 10, distance 3.5, and the work equal to 7500 times 3.5, 26,000 negative 250 joules. This is a work done by gravity. Negative because of direction. Yes, weight is downward, but it moves upward. That's why negative. Now let's come to the work done by tension. Work done by tension. Of course, first we need to find tension. Work is equal to tension times distance. Tension is a force. Tension is not given, but work should be positive because tension is upward and it's moving upward, so it should be positive. Now question is tension. How we can find tension? I think initial velocity given, final velocity given, distance given, so we can find acceleration. Then once we have acceleration, we can find tension. So first let's find acceleration. So we know that this is a motion with constant acceleration. So let's apply this equation. Final velocity equal to initial velocity plus, because it's accelerating, velocity is increasing. So we can apply this equation. 0.75 square equals 0.25 square plus 2 times unknown acceleration times 3.5 meters. So from here, acceleration will be equal to, let me do it quickly for you, 0.75 square minus 0.25 square and divide by 7. Divide by 7. So it's approximately 0.071, but let me write it in this way. 1/14. Acceleration is equal to 1/14, or 0.071. Now we can apply Newton's second law. Tension is upward, weight is downward, and we know that it accelerates upward. Due to the Newton's second law, we know that tension minus weight, this is a resultant force, should be equal to ma. Tension unknown. From here, ma plus mg equal to tension, or we can say a plus gravity. So tension equal to mass 750, acceleration 0.071, gravity, let's take it as a 10. So tension will be equal to, let's do it quickly, 750 times 10.071. So answer is 7,553 joules. Not joules, sorry, this is a tension. This is Newton. Now we know what is a tension. So let's come to the work. Tension times distance, 7553 times 3.5. So work will be 26,436 joules. So this is the work done by tension. Of course, this is a video lesson, so you can pause it at any time and you can try to solve it yourselves. Then you can again click on play button and watch the solution. Question 50. I selected some useful problems for you. Question 50. You are fishing from a tall pier and have just caught a 1.5 kilogram fish. as it breaks the surface essentially at rest. The tension in the vertical fishing line is 60 Newton. Use work and energy to find the fish's upward speed after you have lifted 2 meters. So we have a fish. This is our fish. And here we have rope tension, yes? And initially at sea level, velocity equal to 0. Let me write like this, initial velocity equal to 0. And using work, energy, and energy to find its velocity speed after 2 meters. So we should find fish's velocity after 2 meters. Yes. So basically height equal to 2 meters or x equal to 2 meters. So this question is asking to solve this problem by using energy method. Yes, work method, energy method. So actually we can also solve it by using Newton's second law and kinematics, but no, we need to use energy method. Okay, first this is initial level, yes, initial point, and the fish will be here after some time, and we will say this is the final point. And we know that according to the conservation of energy, initial energy should be equal to final. Yes? Final. What is initial energy? No velocity, no height, no kinetic energy, no potential energy. But why this fish is going up? It means someone is giving some energy. Of course, this energy is due to the tension. Tension is doing some work, and that's why this fish is going upward. So as initial energy, I will write work done by tension. So tension times x or h, yes, because it's moving in vertical direction. And finally, it will be at this point, and it will be moving upward with certain velocity. It means fish has a kinetic energy. And of course, there is a height. It means this fish has a potential energy. Yes, you see just one equation. So your aim, your job is learn how to write, how to apply this kind of conservation of energy for any situation. Now we can solve this problem. Tension is given, height is given, so very simple. 16 times 2 meters equal to mass 1.5, velocity unknown, over 2 plus mass is 1.5, gravity, let's assume it 10 approximately, times 2 meters. So 32 minus 30 equal to 1.5 over 2 v2 square. So from here 4 over 1.5 equal to v2 square. So from here v2 equal to square root 4 over 1.5, approximately velocity equal to 1.63 meter per second. So this is how you need to apply conservation of energy. Now let me shift to the different book, survey, and question 14. Question 14. The force acting on a particle varies as shown in the figure. Find the work done by the force on the particle as it moves from 0 to 8 meter, from 8 to 10, and the last one from 0 to 10 meter. So let me remind you that equation for work that we used it in previous questions, force times distance. You can use this equation if force is constant, if you have a constant force. Now let's pay attention to this problem, question number 14. Force is not constant. Initially it was 0, then it becomes 6, then again 0, negative means change this direction, etc. So what we can do in this case? We cannot directly use this equation because force is not constant. So what we can do, actually we can apply area method. Area method, you know that, for example, if you have a velocity time graph, speed time graph, then area under the line gives us distance, yes, displacement. The same logic we will use here. Pay attention. Work is equal to force times distance, multiplication. So it means area under the line also will give us work for this problem. So we have this kind of graph. In the first case, maximum force is 6, and here is 8 seconds. So basically area here will be equal to work. So this is a triangle, yes, a triangle. Area of the triangle is equal to what? Height. This height equal to 6 times base. Base is 8 divided by 2. So answer will be 24. Yes. So work done by this force, varying force in 8 seconds equal to 24 joules. Second question, work done by this force between 8 and 10 meters. So you see, force becomes negative. It means it changed its direction. Force changed its direction. Let's say before it was moving to, force was applied to the right. Now the force is applying to this object to the left. So we need to find this area. Let's call it area 2. Yes, this is area 1. So this height equal to 2, base equal to 2. So work 2 equal to A2. Of course, this work will be negative. Yes, because it's still moving to the right, but force is applied in negative direction. So that's why negative. Height 2, base 2 divided by 2 equal to minus 2 joules. Now, last question, total work, yes, between 0 meter and the 10 meter. Total work equal to work 1 plus work 2, which is 24 minus 2, it will be 22 joules. This is the total work. Next question, 59. Let's find question number 59. 59. Okay. Very good question. Question number 59, sorry. Question number 59. So first read the question and try to solve it. You can pause the video. So we have a 6,000 kilogram car rolls along the rails and with negligible friction, no friction. The car is brought to the rest by a combination of two coiled springs as illustrated in the figure. So we have a car, heavy car, 6 tons, 6,000 kilogram, and this car is brought to rest by the help of two springs, not one, two springs. Both springs are described by Hooke's law and have spring constants K1, K2 given. After the first spring compresses 30 centimeter, the second spring acts with the first to increase the force as additional compression occurs as shown in this figure. The car comes to rest 50 centimeter after first contacting the two spring system. Okay. So you can pause it and you can try yourselves, but I cannot pause. I cannot wait. I will continue. Question number 59. Initially it was moving. Car was moving. So initially we have a kinetic energy, yes? So we should use conservation of energy. Initial means before contact with spring. Final means when car stops, when velocity of the car becomes 0. And at this case, spring will be compressed. Yes? X1 will be, first spring will be compressed to 50 centimeters. It was given. And you should find how much centimeter will second spring will be compressed. So first one compresses 30, then second one acts, then totals 50 centimeter. It means second spring will be compressed for 20 centimeters. Second one will be compressed for 20 centimeters. First spring will be compressed for 50 centimeters. So let's write it here. First one, 50 centimeter. In meters, it will be 0.5 meter. Second one only 20 centimeter, 0.2 meters. Now, what is initial energy? Of course, we have only kinetic energy of the car. Finally, two springs will be compressed, so it means, and the car's velocity becomes 0. So no kinetic energy, only spring energy. We have two springs, so we have two spring potential energy. That's all. So we can cancel 2. mv square equal to k1 x1 square plus k2 x2 square. Mass is what is the question? Find car's initial velocity. Mass is 6,000, velocity unknown. We should find k1 1,600, x1 0.5 square, k2 3,400 times x2 is 0.2 meters, yes, square. Here we can cancel, we can divide both sides by 100, so we can cancel, we can remove 2 zeros. Now 60 v square equal to here 16 times 0.25 4, here 34 times 0.04, it will be 1.36. So answer will be 5.36. So v square equal to 536 divided by 60 divided by 60. So it's approximately 0.09. So it means velocity approximately equal to 0.3 meter per second. This is the initial velocity of the car. Now question 63. Question number 63. Question number 63. 6 and 3. An inclined plane of 20 degrees has a spring of force constant 500 fastened securely at the bottom of the surface. A block of mass 2.5 is placed on the plane at a distance of 0.3 from the spring. From this position, the block is projected downward towards the spring with initial speed given 0.75 meter per second. By what distance is the spring compressed when the block comes to rest? Inclined plane, initial position. Spring initially was like this, yes? Spring is not stretched. After some time, object will be here, yes? And the spring will be at this position, so spring will be compressed for a certain distance x. This distance initial equal to d. So question is, by what distance x? And we know that initial velocity given. So very simple. This is the initial level. This is the final level. As you know, energy should conserve, yes? Initial, final. And pay attention, height of this object is decreasing, yes? This is initial height. It means initially there was a potential energy. And also it had a velocity, it means kinetic energy. That's all. There is no any other energies because spring initially was unstretched, so no potential energy of the spring. Finally, spring is compressed, so spring energy, potential energy of the spring. Velocity of the object is 0, height 0, yes? That's all. What about this height? Is it given? So let's pay attention to this triangle. This is a right triangle. This angle is given 20 degree. Let me draw it separately so you could see it. 20 degree height. The hypotenuse of this right triangle actually d plus x. D plus x, not just d. So what is the height? Height is d plus x hypotenuse times sine alpha. Now let's continue. Mass times gravity times d plus x sine alpha, kinetic energy equal to kx squared over 2. Mass is given 2.5 times 10. And what is it? D is 0.3 plus x unknown sine 20 degree. Mass 2.5, velocity 0.75 square divided by 2 should be equal to k 500 divided by 2 x square, x unknown for now. So we need to we have this kind of equation, we need to find x. We need to find x. What is a sine 20? Sine 20 equal to 0.34 times 25 times 2, 17.1. So 17.1 x plus 5.13. Here 2.5 times 0.75 square. So I multiplied both sides by 2. Let me check. 25 times sine 20 times 2. Yes, I multiplied both sides by 2. So 2.5 times 0.75 square, 1.4 equal to 500 x square. So 500 x square minus 17.1 x minus 6.53 equal to 0. So basically we need to solve this equation. We have discriminant, so x 1, 2, we have two possible answers. Minus b 17.1 plus minus 17.1 square minus 4a c is negative number, so 5.53 divided by 2a, 2 times 500. So answer, of course we cannot use negative number because the right side will be less than, right side is bigger than 17.1, so you will get negative number, which is physically wrong in terms of physics. So plus here 17.1 square plus so finally x equal to 0.13 meters. So in centimeters it will be approximately 13 centimeters. This is a compression of the spring. Now you have a homework. So from which book? Just 1 second. 44. Just 1 second, let me find homework for you. Yes. So this is the first example. First one, first task. Then second one is this one. So this is also your homework. You know how to do it. You need to record video, as I mentioned before. Only 2 questions. I will tell you about deadline later. Thank you very much.